Welcome to a video on trig functions of compound angles. So these are the 6 compound angles. We are going to start by proving each one and then we'll look at one example. So to start with the proof, so we start with a triangle that has a angle of alpha minus beta. So alpha is in the second quadrant, so it would have the coordinates r cos alpha, r sine alpha. So x is obviously cos and y represents sine, and b has the coordinates r cos beta and r sine beta. Now this is on the unit circle x squared plus y squared equals r squared, hence the radius of r that we had. So if we find the distance between the 2 points using the distance formula, so that's d squared equals y2 minus x2 minus x1 squared plus y2 minus y1 squared. So just using those points. If you then expand that, so like expanding a quadratic, square the first, twice the product, square the last, you end up with the final one you've got there, which is ab squared equals r squared outside of, and squared alpha minus 2 cos alpha cos beta plus cos squared beta plus sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. One of our rules for trig identity says that it's cos squared plus sine squared equals 1, as long as it's the same angle. We've got 2 there, cos squared alpha plus sine squared alpha, that's 1, and cos squared alpha beta plus sine squared beta also equals 1. So that gives us our first rule if we take the 2 out the front. So our second formula comes from the cosine rule. A squared equals b squared plus c squared minus 2bc cos a. So in this case the angle is alpha minus beta. The radius is, or the lengths of your b and c are r and r. That gives us a formula. ab squared is 2r squared outside of 1 minus cos alpha minus beta. So now we're going to equate those two. So the yellow one was the first one we got, the blue one was the second one, allowing them to equal each other. And then if you divide by 2r squared on both sides, that leaves you with 1 minus cos alpha cos beta minus sine alpha sine beta, 1 minus cos alpha beta. Subtract the 1 from both sides. So when you subtract the 1 from both sides, then divide by the minus or multiply through by minus 1, you get the formula we're after. Cos alpha minus beta is cos alpha cos beta plus sine alpha sine beta. The next one is start with our rule that we've just proven and replace b with minus b. So the first bracket is obvious, that gets you cos of alpha plus beta. But when you replace minus b in the cos beta and the sine beta, cos of minus beta is in that fourth quadrant, so cos b is positive, and sine of minus beta in the fourth quadrant is negative, so that's minus sine beta. So that's why we get cos alpha plus beta equals cos alpha cos beta minus sine alpha sine beta. So moving on to the first sine compound angle. We're going to start with the complementary rule, which says sine theta is equal to cos of 90 minus theta, or pi on 2 minus theta. So if we want sine of alpha plus beta, that's cos of pi on 2 minus alpha plus beta, using the complementary angle rule. Rearranging that is pi on 2 minus alpha minus beta, and then using the cos expansion, that gets you cos of pi on 2 minus alpha cos beta plus sine of pi on 2 minus alpha sine beta, and of course sine of 90, cos of 90 minus alpha is sine alpha, and sine of 90 minus alpha is cos alpha, and that's how we get the rule. So for this one, we just proved sine alpha plus beta, so now we're going to replace the beta with minus beta, so that's why we get sine of alpha minus beta. And then we get sine alpha cos of minus beta, cos alpha sine of minus beta. And in one of the previous ones, we showed that, talked about that cos of minus beta is actually positive cos of beta, and sine of minus beta is sine minus beta. And that's why we get sine alpha minus beta is sine alpha cos beta minus cos alpha sine beta. So now on to proving tan of alpha plus beta. So we know that tan is sine over cos. So tan of alpha plus beta is sine alpha plus beta over cos alpha plus beta. Write the expansion of those two, so from what we've proven before. And if you divide each term by cos alpha cos beta, you end up with tan alpha plus tan beta over 1 minus tan alpha tan beta. Same with what we've done before. In the tan alpha plus beta, if we replace with minus beta, you're going to get tan alpha plus tan of minus beta over 1 minus tan alpha tan of minus beta. Now tan of minus beta goes into the fourth quadrant. It's also negative, hence why we get tan alpha minus tan beta over 1 plus tan alpha tan beta. So here's our example. Find the exact value of sine 105. So being sine of an angle, that generally means we're going to use the sine expansion. So using sine alpha plus beta in that expansion, sine of 105, well, 105 is made up of 60 and 45, and we know they're both exact triangles, so try and go with those numbers for the exact ratios. So sine 60 is root 3 on 2, cos 45 is 1 on root 2, cos 60 is a half, and sine 45 is 1 on root 2. That gets you root 3 on 2 third 2 plus 1 on 2 third 2, which gets you root 3 plus 1 over 2 third 2, rationalising your denominator. You get third 6 plus third 2 over 4. Thank you.